all started, as you know, with this book. Anyone knows about this book before? The Django 4, some people knew about that. This is a very famous book, right after the invention of object-oriented programming. These guys came up with this idea, took it from Christopher Alexander, applied it to computer science, and it's fairly, well, the examples are for, we'll see, for C++, people. This is the first book. This Eric Gamma, Richard Helm, Ralph Johnson, and John Felicitas referred as the Django 4. So it started with this. It's very, when you check this book, you know how popular it is in Amazon.com, you will understand. So this is one book. We have the Java version for it. There are many books around. Well, this is explaining all the patterns in Java. I don't know. Not really a big fan of it. It turns out that this one is good. Design patterns for dummies. Well, there are some patterns that you will be able to find in other books. So, another one. And this is the head first design pattern, and I'm taking the examples from this book. It's really fun to read. I don't know if you ever read Head First series before. Yeah, it is a very different approach, and I like it. The examples are nice, and
we can take a look at download the Head First.
Well, this one is very good. This is, but this is more advanced. I have to say, refactoring to patterns. This is more advanced, but very nice. Very nice book. I mean, if you wanna take a look, please do so. Well, so I will start with the most, famous one of them. Well, of course, the most famous one of them is factory. I'm not going to start with that, but we'll start with something else. Of course, all the time I'm going to be giving some examples from not, from a domain that we can all understand. But for this case, our domain is ducks. So here what we have is that we have several types of ducks. Okay, so we have the mallard duck, we have the red-headed duck, so different ducks we have. So normally as an object-oriented programmer in our world, what we do is, I don't know if you do the same, immediately when I have such an object that I have to write a program about it, I say, okay, well, there are different types of ducks. So what I do is that I have a super type, and then I have concrete classes out of that. I mean, I have a duck. Like this is, you know that notation, don't you? I mean, when it is italics, it is a super type interface. And these are concrete ones. So what I have is a duck, and duck, well, of course, I immediately start with what a duck do. What a duck does is that, it quacks, it swims, and it shows itself. So I have to, simulate the duck. So it will be making a sound, it will be swimming, and it will be displaying itself. So, like, whatever it is doing, like displaying the quack, how the duck is swimming, it displays that. So what I do here is that I am implementing the things that are, for example, display, well, this one looks like a mallard duck. I put in the code that is making this dog looks like a mallard duck. And this one looks like a red hat dog. So this is the idea that we have, right? So what happens is when I want to add something, like I decided that, oh, okay, ducks do fly, so I will add that future as well in here, and I will say, I put it over here, so it's easy. You know, this is a nice design. If any elements that I want to add, I add to the super type, and then it is reflected all the others. So I have to, of course, implement them over here. If they do fly differently, or I can make this not an abstract class, but I can make it a concrete class. And so all the things that this guy is doing, I don't have to implement them over here. So we got the picture, right? So, well, so far so good. But what happens then if in my world the customer turns out and he says, look, it's all fine with this design, but you know what? We want to be able to simulate rubber ducks as well. Okay, no problem. So what I do is, well, I change this quack with this squeak. So I need to change the sound. In my world, or for my customer, it doesn't matter how differently mallard dogs and red hat dogs are quacking. Maybe there is a difference, I don't know really. But in my customer doesn't care. So, but my customer do care that if this guy here, this rubber dog here, really quacks, it's a problem. My customer doesn't want that. This has to be squeaking. So when you squeeze it, it has to have a different sound. So I have to do this. So this is going to change. Well, but there's another problem. The other problem is that rubber ducks do not fly. So what I do is that I override it, and I would say do nothing. Okay? It will not going to do anything. So it will just, when somebody calls that future, it's not going to do something. So I'm going to add that. And my customer says, all right, we want a decoy dog as well. So the difference with the decoy dog, it doesn't quack. So when somebody calls that, it's not going to do something. So here it is, you know, the total thing, the full thing here. So what I do, maybe, if I have it as an interface again, not an, you know, another concrete class, I make it an interface because you know what? I don't know if you're familiar with that terminology. You try to design to an interface, right? Did you ever heard about that? One of the principles of object. Did you? You have to be, you know, instead of inheritance, you have to go for interfaces. Well, in C++ world, I believe that is virtual classes. Yes, virtual classes. And so in that case, what I'm going to do is that, well, all the ducks do swim and all of them do display themselves, of course. And what I do is that for mallard dog, I have this flying and quacking functions here and here again. So I can change my design like that. But the problem here that, you know, whenever there is a repetition in the code, that's not a good thing that we don't like. We don't say that this is a good design, right? When we do write the, you know, when we are writing the program, we say when you repeat the code, for example, what you do is that you're copying and pasting. That's a bad thing, right? Do you agree with me?
Yes.
It's a bad thing because if something changes, then you have to change it, you know, in all the occurrences of where, you know, wherever you pasted, copied and pasted it, you have to change them all. It's a bad design. It's error prone. So what I have here is this. Well, these two things do exactly the same things, like flying and quacking. So it doesn't work. This is not a nice thing. So what can I do in this instant? Is the core of strategy pattern. So what we normally do, we take them out. Okay? And we say, let's put some interfaces. Let's call them flyable, backable. All right? These are two interfaces. So what I'm going to do is, I have a duck. All of them are coming from this duck. Like this is an abstract duck, and they are inherited. And then I have these abilities of the duck. Some of them are flyable, some of them are quackable, makes the sound. So this too is both flyable and quackable, and this rubber duck is only quackable. So what I do here is something like when I talk about, for example, the mallard duck, like this is a class, right? How do I, well, all of us are, I think I need to move this one here. Well, first of all, it is inheriting duck. This is duck in the abstract class. This is, how do I do this? Do I say this? Am I correct?
Yes.
And, well, it implements flyable and quackable. So what do I do? I say
Implements.
Implements. I forget things, you know. Flyable and quackable. So this is what I do. So, well, is this solving my problem?
No.
No, because again, I need to repeat. Right? So, what I need to do is this, that I have a duck class. And, well, it is consisting of some attributes, of course, that I didn't show here. The duck class has some attributes about maybe the weight of the duck, the color of the, no, not the color maybe, well, maybe the color, and some features about the duck, attributes. But then there are some methods. Attributes are easy to change. I can call gets and sets, you know, the getters and setters, and I can change them easily. But with the behavior, it is not like that in this design. I'm not able to change them. I can change the weight of the duck. In the runtime, I can say, set this, you know, whatever duck's name it is, that object, and set the weight 200 grams. That's easy. But how about the flying ability? How the duck is flying, or how it is quacking? It is not like that. So what I need to do is actually to be able to make the behavior also changeable. So you're able to change the behavior too, right? So can you do that when you're programming something? Like you have a class, you have attributes, you have getters and setters for that. But you have some behaviors as well, some methods. You want to change those methods in the runtime. Then you will be able to say, set this behavior to this. Can you do that? So, well, of course you can. So you have this fly behavior, for example, as an interface. And it says fly. And you have some concrete behaviors here, concrete classes. And you say fly with wings and fly no way. If there is another quack, like a remote controlled quack, well, it flies with a propeller or something. Okay, so I have different fly behaviors. This is an interface. Well, exactly the same interface that I was mentioning here. Maybe. Yes, this one. Like flyable, quackable, so well, it does fly, it does quack. These interfaces are using this. These concrete classes are using these interfaces, right? So, but what these interfaces are doing? These interfaces are doing this. Actually, it has to be doing that. Instead, I say, look, I have a fly behavior. This is an interface. And I'm defining different flying behaviors. So now what I can do is I can exactly do the same thing like with the attributes. With the attributes I can have getters and setters, right? And I can do the same with this now. Like the same with the quack behavior. I have the quack interface and doing all of these things. So, oh, what did happen? Okay. Nice. So, okay. So the difference is this. When I have a concrete implementation, well, at least in, I don't remember, at one time, it's been a long time I've not programming in C++. So we need your expertise on that. This is what happens. When you have a concrete implementation, this is how you do it. This is a dog, and you use the same name here and here, right? So when it is an interface super type, you have this animal, and you use dog in here, right? This is the super type, and this is the dog. So what it does is that animal makes sound, because bark, we don't know if it is barking or quacking or just making another sound. So this gives us a flexibility when I program to the interface. Of course, if I'm designing my world with an interface, then I wouldn't be using this kind of a constructor, constructing line to construct an object, to initiate an object. I wouldn't be using this one, right? I would be using this. Suppose that I can even that I have this, for example, even I have this design, I have this animal. The dog is inheriting this animal. I can still write this right, can I? I can write this. Wouldn't give me an error, but that would be a stupid thing to do most of the time. This makes more sense because then I will be able to transfer this information, transfer this object to other objects, and without really knowing about what it is, if it is a dog or a cat, right? So I don't care. What kind of sound it does, I don't know, and I don't care. So this is how it is, and with that, I can, for example, get an animal from somewhere without knowing what animal it is. When I'm getting this, I don't know what animal it is. It is a cat or a dog or I don't know, a horse, a donkey. I don't know, so it is transparent. I have no idea. This is the beauty of it. So I will be able to transfer methods with that as well. Is it clear? I mean, this is something probably that you are already using. This makes more sense than this one. It gives you the flexibility. So when we come back to our duck example, I'm transforming my duck design into this. You know what? My camera has a problem. It stops after 30 minutes.
It's fine now.
So just tell me when it stops. That means that it's time for a break.
Okay.
Duck class now is like that. This is the abstract class that I have. I have a fly behavior. This is an interface, and I have a clock behavior. And maybe there are some other attributes as well. And so I'm transforming, I'm adding these two, perform clock and perform fly. And within these two methods, all I do is to call fly behaviors fly function, and in here I call clock behaviors clock function. Right? Because these are, what are these? These are, again, these are interfaces. They are referring to some concrete classes. And those concrete classes have only a method inside them, nothing else. This one has a fly method, and this one has a clock method, right? All I need is one method. And since that I encapsulate that method within an object, within a, one object, one class, I'm able to send it from one object to the other object. I can store it here. So what happens is, when I extend this dock, for the malloc dock, this is the constructor, as you know, where I initiate the object. This clock behavior, I say, let it be a new clock. This is a, remember this. This is a fly behavior, and it is a fly with wings. This is a clock behavior, and this is a quack. No, this is what?
Quick.
What was it? Yeah, that was a quack, yes. So, and what happens with the abstract class dock? I have a fly behavior. This is an interface, this is an interface, and these are, of course, some objects now. So I can, when they're an object, I can store them, and I can then call them, call those functions. So now what I have is, normally I have getters and setters to be able to change during the runtime my attributes. Now I have getters and setters, and I can change the methods of a class. So, well, sort of. So overall, it looks like that. I have these guys. I have these interfaces. I have, so what happens is, the beauty of that is, I have this package, for example, and I can add, when somebody asks for a different, maybe I have some slides for that. Maybe I don't. So anyway, I say it. So the beauty of that is, well, you can add more clocks, for example. If I have a, like as I said, if I have a fly behavior, now I decided, my customer said, I want to have a remote controlled duck, a decoy duck, which will be flying with a propeller, that I will be flying it. So no problem. What I do is that I create a new concrete class and inherited this interface and implement this fly method. And then what happens is, I will create a new remote control duck out of this. And all I do is that I change, and I will put this in here. For the fly behavior, I will put in the constructor that it is its fly behavior is remote controlled fly behavior, and it doesn't make any sound, maybe. Or I can turn, during the runtime, I can make a malloc duck look like like a rubber duck. All I do is that with the getter and setter, I can turn it, I can call it is fly behavior and change it over to a squeak instead of a quack. So, that is called the strategy design pattern. Did you know about that before? Were you using this? No? Some people, hence? One people, okay, good. Oh, I like that. Oh, I of course didn't like that, you didn't know, but that's the purpose of this class. So now you know it. So,
Can I have
Yeah.
ask a question? In the slide before,
yeah.
I'm asking because not all languages have interfaces. If I had an abstract class instead of the interface, wouldn't that work?
Yeah, if you have a virtual, you mean in C++, for example, or
No. I mean, like, as I understand, I didn't use C++ to that extent, but if a virtual class stands for an interface,
Yeah.
then that's not what I'm talking about. For example, in Ruby or Python, we don't have interfaces,
okay,
but we do have an abstract class. There is a slight difference, I understand, because then it would not enforce the implementation of the fly method. You would have to remember to override it each time.
yeah. In this case, yes. With
But-
the interface, you have to remember that you are implementing it. But the important bit about this is not about forgetting or not forgetting. The important bit in here is that to be able to swap behavior during the runtime. So that is the critical thing. I don't know about Python, but maybe we can find out if you type in Google.
No.
There's a strategy pattern for Python. I know that there are of course design patterns written for that language as well. So okay. So well, in this you will be doing some work as well. And pen and paper, please. Let's say that I have several characters, and using the things that I just told you, I want to be able to make a design that is swapping these characters will be able to have different behaviors, weapon behaviors, I told them. Well, we don't know what it is, but I have different, like Queen uses, okay, well, Troll uses the axe, that's for sure. Queen uses knife, maybe. It's up to you, you make it up. And Knight uses a sword, I don't know. Anyway, so you can make your mind up about which character is using which. But the idea is that can you please make these characters flexible enough to have any weapon that they would like as a method. These are methods. During the runtime, we will be able to change their weapon behaviors. Sorry?
They will know what buttons you
They will be able to change their weapon behavior. Yeah, can we turn